Hey guys, thanks for joining. This time I'll explain how Boolean operations can be used in um, bit by bit and when using the Open Cascade technology kernel that is exposed in this category. So there are three basic Boolean operations that we have here. So it's union, difference, and intersection. To do that, I will just create two shapes. That we will be using to demonstrate the principle. And one will be the cone, and the other will be a sphere. We'll put the sphere on the higher level of 3, and we'll make our cone a bit higher, and it will be in 3. And let's draw those two shapes now. So I'll use that component. Let's click play. So we'll increase also the radius of a sphere to 1.5. And let's click play. So you see now that we have those two shapes here overlapping each other, but they are still separate shapes. And if I use these options, place them here, let's increase the accuracy. Let's make it opaque, and let's put those same options here, but just change the color to red. So let's click play, and you see that we have those two shapes now intersecting each other. They are connected, but they are still separate. The sphere is full, and the cone is also here visible. So to union those two shapes, we can simply use the Boolean operation that you can find here. So to do that, we will use a list component that is this one, and we'll remove one of the items. So we have two slots available here, and I'll just copy paste this sphere to go here and this cone to go here, and I'll also just disable these components for now. We don't really need to see that at this point. And let's click play. Yeah, so union was made, but I forgot to draw it. And to do that, you just need to drag this component in. And let's see. Okay, so now it's visible. And now you see that there is an edge that was formed between those two shapes. And another thing is that if you would use these options where transparency is applied, you wouldn't see the sphere that goes inside the cone, and you don't see the cone that goes into a sphere. It's just connected now. So the union was computed, and you're done. So union can be done also on more than two shapes. Actually, you can union many shapes in one go. And let's do that. So let's put another sphere on the fifth Y unit, and let's click play, and you'll see that now a third shape was added into a pile. Okay, so I guess the union is quite clear how that works. We can now look into the Boolean difference between two shapes. And this is used to carve out one shape from another, or multiple shapes from some other shape. So let's use the cone as a base for that. And let's put a copy of that list with two spheres inside. So let's first disable that. Let's also put that here. So we have two spheres. I'll put this one on the 0, and I'll move it a bit further away from the cone's center, but further on the Z direction. And let's see what kind of shape that will produce. And where is the draw component? It's here. let's add it inside, voila, and let's draw the result. So now you see that there's one sphere that carved out this part and another sphere carved out the top part. So this is maybe even clearer if you move this shape also away. This shape maybe also closer a little, and let's see what the result is. Ooh, there is an error. That means that the computation couldn't be solved. Okay, let's keep it like that. You see that I put the one sphere on the 0, another on 1, and now the result was computed. If I would have placed that sphere on -1, for example, let's see if that would work. Yeah, so that worked fine. So you see now that we have two spheres that carved out the result. And maybe it's interesting also to visualize how those two spheres look like. So we will just draw them again, and we'll use transparency option, and maybe it's also nice to have it blue, for example. So this will just visualize. Oh yeah, I still have to compound those two shapes, so just we'll do that fast. Okay, so let's draw them, and we see how those spheres look like, how the cone looks like, and how the resulting difference was solved. So the last operation is the intersection that can be computed, and this one's also interesting, that I will just use two shapes so I know that they intersect definitely, and I'll just copy paste that list, and I'll use the first sphere that is here. So let's leave that bottom one, so let's remove that one, and let's use the cone. Then let's put that into intersection component. Let's disable those things here. And now we just need to draw the result. So let's draw it, and let's see what happens. So now the intersection between one sphere and a cone is left. This is also an interesting shape, by the way, but that's where the intersection happens. And just to visualize that also more correctly, it's good to maybe enable these two components, but let's make sure that both the sphere and the cone are exactly as we described them here. So let's copy paste the cone. And let's first enable that and enable that, and put this cone into here and the sphere into the red slot, and let's click play now, and you'll see that while the two shapes indeed intersect, only the part that is overlapping is left by the intersection. So that's how the Boolean operations work, and this is how you can use them in your own designs. I hope you enjoyed it, and I hope to see you in the next videos. Bye guys.